Well, thank you for allowing me to come speak today. I appreciate it, and I appreciate all the hospitality I've been shown here in Korea. It's been very, very excellent. So thank you again. I am Roayl Lovingfoss. I work at the National Center for Advanced Materials Performance, which is part of the National Institute for Aviation Research, and I'll be going through how we qualify material systems that are acceptable by the FAA and EASA using our standard operating process. So NCAMP focuses on increasing the efficiency of advanced materials being put into use, both in commercial and defense industries. We do that in partnership with the U.S. Air Force, NAVAIR, NASA, the FAA, and ourselves, along with many of the carbon fiber industry partners, some of which are here today. So how we got started is we started out as AGAT, which is Advanced General Aviation Transport Experiments. And our goal was to utilize and put into the general aviation industry advanced carbon fibers along with their pre-preg systems. This shows a timeline of our activity. You can see that we started with AGAT back in 1995, flowed down to 2005, and then down to 2010. In 2010, we received a memo from the FAA that accepted the NCAMP standard operating procedure for qualification of materials. That includes not just semi-pregs, pre-pregs, and thermoplastics and epoxy resin systems, but also 3D printed materials, cores, film adhesives, paste adhesives, etc. In 2014, EASA followed suit and gave us that same memo. So we are now approved by the FAA and EASA to create allowables, and those allowables are then used to do initial sizing as well as design for aircraft parts using advanced materials. So you can see both of those memos there. We work with the FAA, EASA, DoD, and the industry partners to qualify various types of materials. Those materials are then put into what we call a shared database. That shared database then allows industry partners that may have not been a part of the initial qualification program to then go forth and look at that database and decide whether the materials we have done research on will actually fit a need that they may have. From there, if they decide that that's the case, then they can then become part of that program through what we call an equivalency process, and I'll discuss that a little bit more. So starting out, what does NCAMP really produce? Well, we produce the shared material and process specifications, and that's very important. So you can have all of this data. You can then take all of that data and you can do designing of parts, but if that data is not controlled, and if that data is not controlled all the way back to the materials that created that material as a whole, then you don't have a controlled system. So really we are creating a controlled system or a controlled process to generate the data that we are publishing for use. So once we have the material and the process specifications built, which we do in conjunction with the material suppliers and the end users, then from there we generate the data, which then is turned into the material data and allowables that we publish in our reports. And just to make sure that's fully understood, we are focusing on what is considered the bottom of the building block pyramid, and you see that there in the middle part of the screen. So we are at the coupon level. And we do that by using industry standard coupon tests such as ASTM, EN, and ISO certified testing techniques. So you can see that pyramid a little bit better in this slide. And again, if you look on the right-hand side there, it says shared at this level. We're very focused on the coupon and element level of that pyramid because those are controlled by standard ASTM, ISO, and EN test methods. And we can then generate that data not only within our laboratories, but it can be generated repeatedly in other laboratories around the world. So how does our organization work? Well, we have our regulatory governing bodies, such as EASA and the FAA, as well as NASA, Department of Defense, et cetera. And that flows down to the NCAMP staff, of which I am the director. And then from there, we have our supplier advisory board, which is made up of our material suppliers, our manufacturing advisory board, which is the industry users of these materials. And then we have our performance review team, which are selected experts. So that may be from academic institutions, other research institutions, et cetera. That involves people that are experts in this particular field and material. So we have the FAA and EASA, we have NCAMP, we have the advanced material suppliers, and then we have the end users. And what this really does is it involves and allows the approach from all invested parties. So you have the governing agency, you have the material supplier, and you have the end user. That also promotes the sharing of the information that each of those particular partners has. And it leverages resources from everyone, just not one particular mindset. So material qualification processes. You can see here how our database grows. It allows for the better understanding of the properties. It allows for advanced material manufacturers to understand their process in a much more robust way. It also helps them understand how their end users are going to use these materials. It allows for the equivalency process to grow the database. So the more users we have, the more data we have, the more robust our data system is. And therefore, when we run the statistics, we have a much better understanding of all the sources of variation that may go along with this particular type of material and process. This is just a flow chart that kind of gives an idea of the steps that are involved with creating a material allowable for a particular material and process, starting at the very top with the introduction of the material to NCAMP, flowing through various conformity steps, whether that's creating panels, creating coupons, conforming the test setup, making sure that all of that is done in an appropriate manner, and then all the way down to where we are then generating the specifications as well as the material property data reports that are all published on the NCAMP website and then are allowed to be used once published by the various industry partners. So the benefits of the NCAMP process to the material suppliers, you have the publication of key material properties. That's important to get your information out to the end users. And then the end users can actually understand that, hey, this material data was actually generated in a proper manner that is acceptable by the governing agencies. To the material users, you have your ability to look through a large selection of data so that you can decide which particular material may fit your needs. It allows you to do initial sizing and design of structures that you may want to build out of that material. And then it reduces the time and cost that it takes to get to the upper level of the building block pyramid. So if each material supplier was having to derive their own material data continuously and then having to do that under the regulatory agencies such as the FAA, the process is quite slow. But we are trying to involve all of those partners all at the beginning to make sure that we understand what is required, what the material can do, and then how we can test that material to show its benefit to the industry going forward in the most timely and cost-efficient manner. And then to the governing agencies, it reduces the workload by eliminating a bunch of repeat material qualifications, right? Because when these materials started to come along in the early 90s, everyone was testing these materials and everyone was getting different results. So it didn't matter if it was Toray or Hixel or Teijin or Solvay or all of their predecessors, because they've all bought each other and changed names 100 times. But what they did is they were all going through these qualification processes. They were all saying that, yes, my tension is 12 KSI. Well, the next time somebody tested it, it was 42 KSI. And the next time somebody tested it, it was 112 KSI. And the FAA said, wait a minute, this doesn't make any sense. So we need to standardize this process, and that's really what NCAMP has done, is just standardize the process to make sure that we understand this is the tests you run, this is how the material is processed, this is how you do the data analysis, this is how the allowables are generated, this is how the specification limits are generated. So the NCAMP steps, again, the customer contacts NCAMP and they say, hey, we would like to be part of a qualification process. That can either be done through the FAA, that can be done through the material user, or it can be done through the material supplier, or a combination of any of those types. Using the established test matrices that we have, we will generate the test matrix at NIAR, and then that will be approved by our NCAMP governing body and board. Once the test plan is created, then we move into working with the material supplier on the material specification, which is describing that material in detail so that there's no ambiguity about which material is being used and the raw materials that go into creating that material. And then we work with the material manufacturer to then come up with the process spec. That process spec, again, is making sure that the process that is used to create that material is well understood, it's repeatable, and it's robust. One thing that I like to point out is that these are not research materials, these are bulk commodity materials. So these are not materials that we're creating in beakers and then, saying, hey, what do we do with this? This is materials that are created on a grand scale, right? They're meant to create tons and tons and tons and to be sold in mass production throughout the world to the aviation industry and beyond. So once all the documents are created, we have what's called an airworthiness engineer representative. They review all those documents to make sure that everything makes sense, right? That I haven't created some terminology or some route for gaining material qualification that doesn't make sense. And then the material supplier goes through an audit. That audit list is labeled there. We start with the PCD. We look at documents called out in the PCD. And then we look at everything from post-processing techniques to shipping to employee training records, the organization, et cetera, of that particular government and or material supplying agency. Once the materials are produced for the qualification, then they're moved into the testing area, and they have to come to the test facility using some sort of CFC or C of A that says, yes, they were produced correctly, and yes, they were purchased correctly, and yes, they are stored correctly. Once that's done, they're created into either panels or coupons, billets, whatever is needed per the process specification. And then from there, created into coupons. Those coupons are then conformed by the AIR, the Airworthiness Inspection Representative. Again, another step in the conformity process to make sure that everything is done correctly. Once that's done, then they go to the testing phase. The testing phase is reviewed by the AIR to make sure all of the equipment is actually appropriate for the tests that are called out in the test plan. And from there, the testing is witnessed by the Airworthiness Engineering Representative again to ensure that the data makes sense from coupon to coupon, as well as the proper failure modes are received. And from there, then that data is considered usable for the statistical analysis. The statistical analysis is done. 2 reports are generated. Those reports are the statistical analysis report, as well as the material property data report. Those, along with the material spec and the process spec, are then published by the NCAMP staff to our NCAMP website. And once they are published, they are considered applicable for use by the FAA and EASA. So here's the different types of properties that we look at. You can see that we do lots of mechanical tests. We also do chemical and physical evaluations, and we do that at different test conditions. This gives you an idea of a lamina test matrix. You can see that those are fairly simple stacking sequences, as well as fairly simple tests at various environmental conditions. You'll notice that it's a 3 by 2 by 3 test matrix. That means that you have 3 batches of material, 2 process runs or 2 cure runs, whatever you want to call that, and then you generate 3 coupons from each of the panels processed in one of those. So you get a 3 by 2 by 3, which gives you 18 coupons for each mechanical test as well as environmental condition. That is a statistical number that allows for a B-basis allowable to be generated. So as I was saying before, the AER is witnessing those tests, and those green arrows are pointing to the tests that the AER is witnessing. They witness 1 or 2 of each test type and test condition. This is the laminate test matrix. The difference here is that you will notice that we are doing both quasi, soft, and hard layups instead of just your typical 090s. Here's some currently available NCAMP data sets, and you'll notice a lot of those people are here today representing their materials. Here's some upcoming NCAMP material databases. You'll notice that there's thermoplastics on there, as well as ceramic matrix composite materials, some chopped fiber, some Vardam processes, as well as some metal AM. We also do polymer AM materials as well. So one of those materials was the Ultim 9085. You can see here that this material was actually attempted through an America Makes project about 8 years ago. They came to us because their C of V's were somewhere around 25%. So if you know anything about statistics, you're going to know that if you have a 25% source of variation in your data, your allowable is almost 0. So that means that that material is not usable for anything that's actually going to carry load. So they asked us if we could then, through our process, lower that COV so that the Ultim 9085 material could actually be used in aviation, mostly used in interiors. It is not used on exteriors. And we're actually able to get that down to about 3%. And again, that's because of all of the checks and balances that we do to make sure we fully understand the process and the material at each step. That allows for that COV or those sources of variation to be very low. So that's my presentation. If there's any questions, I'd be happy to answer them. And I'm not in charge of any of our social media stuff, so you're not going to get a hold of me if you go to Twitter or Facebook or any of that stuff. So.
질문 있으시면 하시죠. Okay, I have one question. So if let's think about if there is any new materials which needs new types of new kinds of test method. So in this case, what should you do to get the NCAMP qualification?
That's a great question. So yeah, any type of new material, you can just reach out to me or any of my colleagues at NCAMP, and we can definitely walk you through what needs to be done for getting that new material started with an NCAMP qualification. Any type of new test method, we continually review test methods all the time at NIAR and NCAMP to make sure that we are using the best method available to the type of material that we're using. So a good example of that is the Ultim 9085 program. It acts a little bit like a composite material, and it acts a little bit like a neat resin material. And so there are some test methods out there that are geared towards composite materials. There's test methods out there that are geared towards neat resin materials or non-reinforced plastics. And so we did a lot of research, especially on the compression side, to find out which of those test methods would work best with the particular material that we're using. And so for the Ultim 9085 qualification, we used a mix of composite test methods as well as your non-reinforced rigid plastic methods. So a good example of that is we compared ASTM D6641 with ASTM D695 Dogbone with ASTM D695 Prisms. And we found that none of those worked very well in their particular written procedures. And so we had to do a lot of modification to make sure that we could actually generate compression data that could be used, that was repeatable, and make sure that that actually gave us good and proper failure modes.
Okay.
Any other questions?
No. Thank you.
Thank you.
Okay. Let's thank the speaker again.